Okay, so we're back into our Excel lessons. The last thing we looked at was we explored the mathematics that would govern an open-top cylinder's volume if its surface area were restricted to 324 units. And we kind of set everything up and used some conditional formatting and dug down into the math to discover that if the radius was 5.86 and the height was 5.86, it would give you this area and it would be the maximum volume possible for that shape. Now what we want to do is consider what if it were a cone. And here's the thing. A cone has only two fundamental variables. The radius of the circular end where it terminates, not the pointy end, but the round end, and the height from the pointy end perpendicular to the round base. So it's going to be kind of the same stuff. It's just that all these equations in here have to be different for a cone. But we'll still want our start in our step. We'll still want to be able to find the maximum volume and have it highlight. We're still going to have our area limited to 324. So basically, there's a lot on this page that I'd like to reuse. And so what I really want to do is duplicate this page. So I want to show you how that works. If you come down here to the bottom, when you're on the tab, and you right-click on it, one of the options is Move or Copy. We're actually going to copy and then move the result. So I'm going to click Move or Copy. To create a copy of your current, and it will only copy your current tab. So it's copying cylinder. I have to create a copy. So it's going to duplicate this. Now it gives me the option of moving it over here before the Fibonacci, or between these two, or between these two, or between these two, or at the end, I want to say move my copy, this new one I make, to the end of these tabs down here. So I'm going to say OK to that. And when you look, it doesn't seem like anything changed up here. This is exactly the same. And of course it is, because it's a copy. Here's the original sheet. Here's the copy. So everything came over. Of course, we're not going to do another cylinder. So I'm going to highlight all the cylinder equations, hit delete here. Now you can see that this one and this one are different. That one is there, this one is here. Notice that by deleting the contents, we did not delete the formatting. And that's good. That's our goal, is to not delete the formatting. Likewise, I want to start again at 1 and 1 for this. Oh, and I need to rename this. I don't want to leave it called cylinder. Now I'm going to rename it and call it cone. Oops. Cone. So now I got to jump in and find the math for that. Now, the math for a cone, I don't have off the top of my head. Well, actually, I kind of do, but you might not. So I want to show you, all you have to do is go online, and we'll type in area of cone. And it gives you this one. Now, here's where you got to be a little bit careful. And this is true anytime you go to pull something off the internet. This is, in fact, the surface area for a right regular cone. It includes the conical portion and the round base. But in our case, we're flipping this thing over. We're using it like an ice cream cone. And the top, the circle, is not going to be there. So we have to look at this equation and figure out what parts of this come from that base that's a circle and what part comes from the conical surface. And it's actually pretty easy. We know a base is pi r squared. So if you take this pi r and you distribute it in to both of these, we find that this first r here is the one that's giving us that circular base. Pi r squared is what we'll get there. So our actual area we're going to do is pi r times the root of h squared plus r squared. Of course, just like before, we're going to have to do some math on that. So let me bring up the old thing to sketch on here, and let's talk about that. So the equation we have is area is equal to pi r times the square root of h squared plus r squared. And what we want to do is guess at some r's and find the resulting h, with a being held constant. So we have to solve this for h. Divide both sides by pi r first. So we get a over pi r. And at this point, I want to remind you, it's very helpful if you're going to go from algebra to Excel to put parentheses around parts of fractions, so that in this way we know that we're going to have to multiply by pi by r before we do the division. So that is equal to the root h squared plus r squared. Okay? I'm going to square both sides. Again, parentheses are really important here. I'm going to go a over parentheses pi r. And then I got to remember this entire thing is going to be squared. That'll get rid of the square root for me here. Then I also want to pull the r over to the other side. So I'll just go minus r squared. And when I do that, that goes away. So now I just got to take the square root of this. So I'm going to take the square root of all of this. I want to take the square root of all of it. To remind me all of it, I put in yet another pair of parentheses. When I take the square root of both sides, the r is already over here, so I got to make sure that minus r squared is part of the square root. Now, you might think to yourself, this is ridiculous, Mr. Dubard. You just included this line to go over the r. That means the r is underneath the radical. You have to take the square root of the entire thing. You have to do all this math first here under the radical before you take the square root. True, you know that, I know that. But as soon as you start trying to write that out in Excel, you're going to run into troubles. So put the parentheses in now, and it'll make all the difference later. So we're going to move that over to here. I'm going to scroll over. Where's my mouse? Where's my mouse? There it is. Scroll over this way so we'll be able to see that equation when we need it. And then the other half of the screen will have be this. So I got to write this equation over here. So H is equal to. Now, similar to the word max, the way you take a square root is you type in SQRT and open parentheses. And it will take the square root of whatever's inside of the parentheses that you generate, this one and the closing one. That's why I had you add the square roots. Why I had you add the parentheses over here and here. Those parentheses there and there are there because that's this parenthesis right here, is this guy right here. So it's automatically in there in Excel, so you should put it over here so you don't short. But then you'll notice that after this parenthesis, there's a second parenthesis. So over here in Excel, I'm going to put in my two parentheses in a row. Then the next thing is the reference to the numerator, which is that, which, by the way, needs dollar signs because we're going to be dragging it down, and we want the same area every time. Then we divide by, and then pay attention over here. I have parentheses around my denominator. Parentheses, pi, P-I, open, close, times is important, R, close paren for this bottom parentheses. So the purple parentheses we see here are the parentheses here and here in this guy. That parentheses there and that parentheses there is your purple. Immediately after your purple one should be another one that matches this, the one before the A. So the next parentheses I put in should be a red parentheses. And I put the parentheses in, sure enough it's red. So those red ones are this guy and this guy, after which we square it. So back over here, all of that gets squared. You have to have both parentheses before the square. If you didn't do that, it would square the denominator. Actually, it would square the C5 and then calculate the denominator, and it would be a mess. So got to have those two parentheses in a row, just like they are over here in the equation, squared. Then minus R, square that, R squared, close parentheses. Notice this last parentheses is black to match the black one for the square root there. So that's just like the two parentheses that I insisted you put this other one over here. That's that last one there. When I hit enter now in my Excel spreadsheet, I'll have to click here. When I hit enter, I get 103.1276. I can double click, brings it down. The volume will be a lot easier. I accidentally put that thing in there. Let me go back to draw and see, can I erase? Can I do this? Oh my goodness. Delete. There we go. They got it. So, all right, cool. So now what I want to do is I want to, let me go back to home here. I want to, in this cell, type in the equation for the volume of a cone. Now, I could go look it up online, but I'll tell you right now it's pretty simple. The volume of a cone is merely, oops, wrong tool. Wait, no, back. I want that tool there. The volume of a cone is merely pi r squared h over 3. So it's interesting. It's the same thing as the cylinder, but now it's divided by 3, which might make you at first think there's no way the cone's going to be better than the cylinder. But as it turns out, the cone actually is better than a cylinder. I'll show you shortly. This divide by 3 makes you think it's always going to be smaller. But remember, our radius and our height aren't going to be the same to idealize the cone as they would be for the cylinder. Your radius is going to be much larger, and since your radius gets squared, that's going to override this divide by 3 here. So, oh, there's an eraser there. I can just do that. So what we're going to do is I'm sorry, I should have left that in there. Let me do this. E equals pi r squared h over 3. All right, so now let me go back to home here. Click on this cell. Set equal to pi times r squared times h. Divide by 3. Now, I personally, again, this is just me and my Excel mania, I would probably put 2 parentheses on here because I like to put parentheses around my numerator. But to be frank with you, this is multiple, multiple, and divide. They're all equal in the order of operations. So I actually didn't have to put those parentheses in there. They just make me feel better, so I'm going to do that. Hit enter, double click, and now we see a significantly larger volume, even unoptimized. This is the best you're going to get on a cylinder. It's 633. We go to the cone, we're already at 677. And we haven't even optimized it yet. To optimize it, of course, we go through the same pattern we did before. We change this to 7 and change this to 0.2. And that gets us 7.6 is a little closer. Actually, 7.8 is a little closer. 7.6 is what I'll put in, though, because I don't know if it's between 7.6 and 7.8. Change this to 0.1. Leave that at 7.6 there because it's right at the top. Change it to 0.02. Now it should be 7.7. That's where I'll go on the top here because it's somewhere between 7.7 and 8. 0.01. 7.71. We're honing in. Change it to 0.002. 7.714. Value to put in there, 0.001 there. And these are getting close enough that, yeah, I don't think we're going to get much better than 680.45. So here, there's not nearly as much of an obvious relationship between the radius and the height, but I do want to point out that this is kind of interesting. That radius of 7.76, that means you're 14 centimeters across this way. That's a very big cone, but the height is 10. It's kind of a cone like that. The height isn't as big as the diameter. It's bigger than the radius, but not by a lot. So we're looking at something that's much more bowl-shaped, and that makes sense that a bowl would be a better area to volume thing than the cone would be. I mean, I'm sorry, not a cone, than a cylinder would be. So not a lot of surprise there that the cone actually is better, even though it has that 3 in the denominator, because you're talking about a much larger radius and the height as well as compared to the cylinder. So that's pretty cool. All right, so that is a mathematical engineering problem solved using Excel. The next thing I want to go to for you is we want to start, we did a lot of stuff with numbers. Numbers, from Fibonacci all the way out to the cone. It's all been numbers. For a brief period of time, we're going to step away from numbers because, as it turns out, Excel also has very robust text management stuff. And so my next lesson is managing text in Excel, just an introduction to it. It's not comprehensive, just like this one isn't. But it's got some cool little tricks in there, and I'll show those to you in the next lesson.